Alright, today we're going to learn the basics of controlling memory usage in SQL Server. Now, typically, when you have an installation of SQL Server in any server, most of the time, when you look at your task manager, SQL Server will be the top user of the memory resource on that server. The reason for this is basically that SQL Server is memory bound. That means that it's more likely to consume a lot of memory than to consume a lot of CPU. Typically, CPU consumption comes if you are doing a lot of SQL compilation. But most of the time, you will find that SQL Server or practically most database systems will consume more memory, the most memory on a server where they're installed. And that is why it's advised to install SQL Server on a on a system dedicated as a database server. So the reason, and you find out that as you begin to use the system, it will continue to consume more and more memory. Why? Because let's go back and look at our instance properties here. There is a setting on the instance called max server memory. If you leave it at default, it's about 2 terabytes, and that means that SQL Server will continue to consume memory until you are out of memory on the operating system. So let's go back to our slide here. We here define max server memory as the amount of memory a SQL Server instance can use. Without explicitly setting this, SQL Server can potentially consume all the memory available on your server and choke the operating system. Typically, I personally recommend that you don't allow SQL Server to consume more than 70% of the memory on your servers. There are a number of reasons for that. First of all, you have to allow for other background processes on the server to work properly. And then if you are working on a server that is being monitored, you don't want alarms going off when you are exceeding thresholds that you really do not need to exceed. Now let's go and do an experiment back on our server here. Now let's look at the usage of memory on this server using the performance tab of Task Manager. Now on the performance tab, we find out that our memory usage currently is about 21%. I'm going to initiate a process which I expect to drive the memory usage upwards significantly, and then we'll see how that grows. So I'm going to create a table out of another table and then begin to insert records into that new table. Let's watch the memory grow as we begin to do that. So right now it's at 21%, and as we go along, I expect it to grow a little bit. So what I've done, I've added 2 other sessions doing the same thing, and I'm driving the memory usage further and further up. And of course my CPU is basically maxed out as this is happening. So we see the memory usage going up further and further, as data is being cached in the operations that are happening are basically storing data temporarily from one table, inserting it into another table, and doing that 20,000 times. And I've driven my memory usage in the last few minutes from 21% to 30%, and it will keep going on and on and on if I let it go. And you can see the memory graph here slanting from the last time we actually started this. So, and that just aligns with what we mentioned earlier, that if we, without controlling this, SQL Server can consume all the memory available on your server and actually choke the operating system. Now I just have 3 sessions doing a very simple thing here. In a production environment, this could escalate significantly, and you will have a situation where your server starts hanging, and when you look at the resource utilization of the server, you discover that SQL Server is the dominant one. This is something that occurs typically in production. See, the SQL Server is dominant. It's about 2 gig. Is the top user of memory here. It's gone up to 2 gig total, and it keeps growing. So you find that when you do a high-level troubleshooting, you will assume that something's wrong with SQL Server because it's consuming memory, but it's simply doing what it's designed to do: use memory as much as possible. We'll go back to the performance. We see we are almost at 40%, and we keep going higher and higher. So now I have 6 sessions doing the same job, addressing different sets of tables. My memory usage has grown from 21% when we started this to 44% and reaching 45%. So I have almost consumed half the memory on the server by this simple activity. Now recall that this is a very fresh installation of SQL Server. There's absolutely nothing production running here. All I have is 6 sessions doing something, and they are all capitalizing on the available memory on the server to run. So we are now approaching halfway, from all the way from 21% usage all the way to now 47%, 48% usage of memory. Okay, so we're about hitting 60% memory utilization. Remember that we started this process a few minutes, less than 30 minutes ago, with 21% usage, and we're at 60. Imagine if you're on production server. Let's say you are this. That means we have actually done 40% addition overhead on SQL Server. Now imagine you are on a production server and you are probably around 60% normal usage and somebody introduces this kind of workload, what will happen is that you will hit 100% utilization of memory just by 6 sessions, doing a select into, that is insert into with a select. Now if we let this keep on going, we will hit 100%. Can you imagine that? Imagine that you have moved from 21% utilization to 80% utilization because of a certain kind of workload, and because of the fact that you have allowed SQL to use as much memory as it needs. So we're about hitting 70% utilization of memory. We started at 21%. Now, typically in certain environments, what people will normally do at this stage would be, okay, let's add some more memory. Yes, let's add more memory. And you keep adding memory and adding memory and adding unnecessary amounts of memory because you are not able to control how this utilization is happening. But there's another way, and that is the subject of this video. Right now we're at 72%. Now the subject of this video is to say I don't want SQL to consume all this memory. Recall that SQL started at about 300 MB. We're now at 7 gig utilization, and it's going further and further. And I showed you earlier that we can actually limit this memory utilization by setting max server memory to something we want. I will typically do a small calculation and say, first of all, how much RAM do I have on the server? I have 16 gig of RAM, and I go to my calculator and say calc, I want to know how much is 70% of 16. Sorry about that. 70% of 16, and that is about 11. So I want to make, maybe just to be safe, I can decide that I want SQL Server to do just about 10 of my RAM. So I do 1148, or I can just say 1048, 1024.0. That's about 10 gig, right? So I limit the utilization of RAM from SQL Server to 10 gig. Now let's go back and see this utilization. Now we're at 82%. So I did that twice and I still don't see a drop. Why? Because of something called lock pages in memory. This allowed the SQL Server service account to hold onto memory and not releasing back to the OS. Local system building account already has this privilege, but if you're using another account to run SQL, you must explicitly grant this. Granting this OS level privilege determines how the behavior that you expect to happen actually happens in SQL. Now, how do you grant this? Grant this from properties, NT service, okay. Alright, so once you do this, for it to take effect, you need to restart SQL Server. Now, Notice the effect of this that we have set up right now. We saw that the memory growing up higher and higher until it's almost maxed out. Now we're going to restart the SQL instance. SQL Server Configuration Manager. We're going to restart it. And this is typically what people will do in production when they get to the point when they cannot control it any longer. They want to restart, and maybe you've been doing a lot of restart of your server every now and then, which is not necessarily the best way to handle things. But let's do that to show the realities that are on ground in many people's environments. All right, so I'm going to start these sessions again. So here we're just gonna drop all our tables, so we start again. Five. I believe we have just 6 of them. Right. So when we do that, we're able to start. Check that there are no tables. So we've dropped all our tables and we're going to start all over again, and so we can watch the real behavior when we begin to do the insert again. Recall that we have set max server memory to 10 gig, and then we're going to just restart SQL again, so we clear all the caches. Once we restart SQL, it drops all the memory usage, and then we're going to start on a clean slate. All right, so we're just about 20% there. We'll check that from here. We also have like 97 MB total for SQL itself. So we're going to go ahead and start running these queries from tab from session 53 or 52. Yeah, the earlier session. Right here. Okay. So start that guy. Make sure it's running. Okay. Start the second. Make sure it's running. Okay. Start the third. This is, yeah, make sure it's running. Number 5, where's number 5? Number 5 should be somewhere. This is number 6. And then let's watch what happens to memory. So memory started climbing to 25 and so on and so forth. Let's see the actual usage for SQL. So the resource monitor gives us a better view of the actual memory utilization. Just to be clear, this is not so accurate. Yeah, so this is active private working set. Okay, but SQL Server has actually cumulatively consumed a total of about 3 gig so far, and that is what shows up in our performance monitor. Okay, so the resource monitor gives us a clearer view of what's actually happening. So we're watching that rise. As it rises, we are now going to be able to see whether we have actually capped it by using the max server memory setting. We've crossed the 5 gig usage specifically for SQL, and of course other components give us a cumulative usage of about 52%. That's a total of 8 gig. So we are looking forward to reaching 10 gig and then being capped there based on the activity we are generating in the database. Alright, so we're almost at 5 at 10%, 10 gig. At about 10 gig, I should expect the utilization to cap around that point. So we've reached a total of 10,707,840, and that is the commit KB. That is where SQL Server can no longer cross. You see, the movement has stopped completely. And take note that the entire memory usage on the server is about 13 gig. That means the extra 3 gig is being used by other components on the operating system. That is why I mentioned that it is important to ensure that the entire amount of memory being used by SQL is about 70%, so that you give an allowance for other components before you hit your threshold in terms of things like monitoring. Reduce this on the fly. Let's go to properties and then let's set this to 8 gig. Okay, yep, 8 gig, 8192. Yep, I believe that is it. So once we do that, what will happen is SQL Server will start releasing memory. Start releasing memory and dropping. So start releasing memory. Watch that. See that? Yeah, releasing memory. That's online. We can actually cut down. Instead of saying I want to restart SQL Server because it's using a lot of memory, we can actually just reduce the max server memory and we'll be able to recover a lot of memory from the instance. Now this is very cool, right? Yeah. Now let's look at other scenarios where we may need this. Recall that what we did was we set the max server memory parameter configuration option on SQL Server to a certain value based on the fact that we want SQL Server to use only 70% of memory. And then for that to work, we needed to make sure that the service account running SQL Server has the lock pages in memory permission. Now, you can always check that. I'll show you how to check that from the event viewer. And then let's look at other options. For example, there's something called stacking in SQL Server, where you can have several instances of SQL Server on the same server or on the same set of servers. When you do that, you need to make sure that the cumulative amount of memory you have allocated to each instance, when you add it all up, that it will not exceed 70% of memory usage on the entire server. You can have up to 50 instances of SQL Server on a standalone server and up to 25 clustered instances in a failover cluster. Then even when you are doing clustering and when you're trying to balance load to optimize your resources or your hardware, you need to ensure that if for any reason all instances happen to run on a single node, that node can support all instances based on the amount of memory you have allocated to each instance, and the sum total of all memory you have allocated should not exceed the amount of memory on that server. So this is cool. So we see that we've been able to control our usage and keep the usage of memory on the server at the amount of memory that we want. And this is a cool thing you can do with SQL Server. Thank you for spending time with us today. So next time we'll probably be talking about how to configure CPU. Have a great day, and do share this video, like the video, share the video, and click the notifications bell so whenever we have new content, you'll be able to see the new things we are doing. All right, thank you very much. Have a great day.